Hello. Hello, hello. Okay, that's okay. So, uh, you can use your WeChat to scan this QR code for the attendance, and don't use the capture of the screen because this QR code will be refreshed every 10 seconds. So, and how maybe some of you do not know how to use this system. I will send you something to help you, the guidance. So I have also sent the guidance of how to check class attendance with WeChat to the group. So if you do not know how to use that, you can. Oh, uh, this QR code will refresh every 10 seconds. So don't use the snap of or capture of the screen. Don't use the capture of the screen. So you need to directly scan it. It will refresh every 10 seconds. Let me try. Okay. Maybe there's something wrong. Mm, okay, I will tell them. Is it expired? Okay, I will try another method. Let me try. Okay, this time maybe okay. Try again. When I scan it, it tells me to log in with the username and the password. I should try. Let me try this one.
It still doesn't work, teacher.
Let me try this one.
The same happened today in the morning. It was not working. And finally the teacher called us by names.
Okay, but now when I scan it, it tells me to log in with my password and the username. So you can try it now.
Maybe because we
Try
are
again.
out of China.
Okay, so some of you can finish that. Try it now again. Try again now. Use this QR code now on the screen.
Oh yes, it's happening, yes.
Okay.
Yep.
Try
What should
again.
I-
Try again. Maybe the network is stable.
Yeah, teacher, it does work.
Okay. Try more because it will refresh every 10 seconds, and the network will be lag in there about the due to network lag. So maybe when you scan the QR code, it has already been refreshed. So try, maybe you should try more.
Teacher, should we click
Yeah.
on submit after scanning the code?
So if it does not work, I can provide you another way. Okay. So we can use another method. Wait a minute. Okay, I have sent a link to the group. You can use that link and for attendance, and I will help you finish that manually. You can also use this link, and I will help you finish that manually.
Sir, we do use our Chinese name or normal name?
That's either one is okay, but remember the student number should be correct.
Okay.
If you cannot use this QR code, you just use that link. I will help you to check the attendance manually after the class. Okay, so let's forget about this QR code. Okay, let's begin. So, here is my information. Name Deng Gang, and it's my cell phone number. You can contact me, and maybe you can also use WeChat or QQ if you like. So, about who am I? Deng Gang. So, I start my career at Huazhong University of Technology, Shangshan Technology, and bachelor's degree about physics and optoelectronics. And again, Huazhong University of Shangshan Technology. And I got my PhD on theoretical physics. And then I went to here, HBUT, as a teacher. And after a few years, in 2018, I went to the University of British Columbia, and for half a year, and then I got back here. So that's about me. So I have got a PhD degree in physics. So that make me good at physics, maybe. So as a teacher, I think that's enough for this job. So okay, let's skip this because you are not here. So what is physics? So these two characters in Chinese, 物理. So in Chinese, when we want to understand a word combined by maybe several characters, we can separate them and explain each of them, and then combine the meaning of them. That's the meaning of this word. So, wu, this is wu in Chinese. It is wu. It means thing. Things means things. Li means theory and laws. So laws and theories. That's li. So when we combine these two characters, 物理 is the law of everything. So 物理 physics is 物理 is the law of everything. So people agree with this, like the Sheldon in the Big Bang Theory. He said physics is the everything in the universe. And this is another movie, The Theory of Everything. It tells us the life of Stephen Hawking. So when we talk about what is physics, maybe you are familiar with this. The universe is physics. Something like this is the electrons and atoms. That's physics. When we discuss this, we can use a diagram like this. This axis means the duration of some process, like time in unit of seconds, from very short period, 10 to minus 10 seconds, to very large time, like several billions of years. The period of the evolution of a star is usually billions of years, like the evolution of a star or a galaxy. And the size of this galaxy usually is more than 10 to 20 meters, but we do not use meters when we discuss the size of a galaxy. We use light years, something like that. Okay, but you can see there's a large gap here because atoms are small. The universe is large. The electrons are very fast. They're moving very fast. So the period is very small, but the evolution of the universe is usually large time scale. But between all these is a large gap. Most of the people do not know between them. That's also physics. Okay, so when we discuss the motion of the Earth go around the sun, that's obviously physics. And when we talk about the lightning and the weather, that's also physics, because just like last year, the Nobel Prize, it's about we use the statistical physics to predict the weather and the satellite around the Earth. And also when you build a house, the mechanism of building this house is physics. And also the energy. The eggs, maybe that's not something you know as physics, but we will discuss this later. And the eggs has something almost the same as the Earth go around the sun. Okay, and lives, and our engines, our people, all these actually they are physics, and they are different from each other, but they share the same physics law, like this. So as I said, the eggs. So here, let's watch this video clip. We have two eggs, and one is boiled and the other one is raw. So we do not have any other tools to help us to distinguish which one is raw and which one is boiled. We just have these two eggs here, but use this experiment, it can tell you which one is raw and which one is boiled. We can rotate them, and then we try to stop them. And this one is stopped very quickly, and this one, when we release it, it go on rotating. So which one is boiled? This one. Yeah, that's correct. This one is boiled. This one is raw. Because in this one, there's something like liquid, right? So when it rotates, and when we want to stop it, we can just stop the shell. We cannot stop the liquid. The liquid will go on rotating, and it will make the shell rotate together. So this, in physics, is called the conservation of angular momentum. This law determines it will go on rotating. This law tells you that's why it will go on rotating. So, but this law, we can apply it on these two eggs when we want to distinguish which one is raw and which one is boiled. And we can also apply it to the planets when they go around the sun. The Kepler's law, one of the Kepler's law, actually, it's the conservation of angular momentum. And now, a few days ago, the Olympics, right? So in Beijing, so when they ski, so when the players are rotating, they can control the speed of rotating. When they spread their hands, they rotate slower, and when they put their hand together, they will rotate very fast. That's also conservation of momentum. So one simple law can explain different things. As small as the eggs and the sports in our daily life, and also the universe, they share the same law. So that's why we say physics is everything in the universe, because we have only several laws, but we can explain everything. So, but we know, maybe you know, okay, that's physics. It helps us to explain almost everything. But what can we do if you know physics? And when people ask me this, it's really a question that very hard to answer that, because this question is not in the scope of physics itself. Physics does not investigate what can we do with physics. So it's actually, this question is not in the scope of physics, but people may ask you this. Maybe you are not study physics. You are like you maybe computer science, right? So in China, if you tell your friends, your relatives, I'm a student in the major of computer science and technology. So they will ask you, can you help me to buy a computer? Or can you help me to fix this computer? There's something wrong with my computer. Can you help me to fix this? But you know, you are not trained to do this, right? So people may not understand what you are doing in your major. So that's the same in physics. So people do not know when you study physics. So what can you do with this? What will you do if you know this? So, but if you are, when you ask me this, so I will tell you, okay, what can we do with physics? If you know physics, maybe you can survive, because in our body, everything is about physics. Our heart is just like a pump. So, just like we just like a system. Our brain is just like CPU, and our neutral system, and just like a circuit, right? Is controlled by the CPU. So that's the same. So when you hit something, you feel okay. So it hurts. It hurts. That's because there are several layers and our skin. When you hit something, when you press something, you can feel it because you press these two layers. These two layers just form a capacitor, and just like capacitor, and our body's neutral system just like circuit. When you change the capacitance of the capacitor, there will be circuits in our electric circuit in our body, and when you send to the brain, this will analyze this signal and tell you, okay, that will make you feel hurt. So that's physics. So, and also where we live, the environment, the earth, the weather of the earth, the motion of the earth is determined by physics, and also the society. So now we use the statistical physics to predict something like rumor in our society, how the rumor spreads. So, but remember, your major is not physics, so we are not to turn you into physicists. So, you are here to start learning techniques used by physics, which are transferable to every field of scientific or technological research. So, so that's why you are going to learn physics, but you are not majoring in physics. So the learning goes, after finishing this course, you are expected to define the fundamental quantities, and you may describe the fundamental laws of physics. These two are the basic goals, and what's more, you are going to learn how to use these laws. So model the real problems with the laws of physics using the mathematical method, and apply the laws of physics to real problems in your daily life, or in your major, or in the industry, and you are going to use the laws to solve them. So these two is the basic goals, and these two we are going to know how to apply these laws. So the model is important here. Like in Olympics, you may see something like this. So what you see is the players. Okay, wonderful. But what the physicists see, something like this. This is just the point. No matter what beautiful styles and you make, that's the same. Ignore that. We just focus on the motion. This is the point. There are several forces on it: the gravity, the air drag. The air drag, why this air drag? Because you are in the air, there's wind, so that's air drag. And your speed may be originally in this, at a certain time maybe in this direction, and it will change. So what the physicists see, like this, just we use a model to describe your motion. And it's not exactly the motion, because maybe you are rotating. When you are rotating, if you use only a dot, you cannot describe the whole motion. We use this dot because when you just focus on where it is, where is the players? you just use this model. That's okay. So models are simplified representation of lateral system. So we use models. So we are not going to describe every detailed information in this system. We use models to let us focus on what we want to know. So we use models to explain the observations, predict outcomes, describe processes. And not only the physicists use models. Biologists, they use models. But their models are more complicated like this. Our models are simpler. So, okay, this is goes. So the books. So you can borrow the books in the library. But if you do so for the guys online, I can send you this one. I can send you this one. Okay. I can send you this one, electronic version. So for the guys in the classroom, you can borrow the hard version in the library. In the library. So library, they have several copies of this one. The green cover. It's a very large book, green cover, and you don't need to buy it because it's expensive. And you can borrow it. And for the guys online, I will send you the electronic version. For the electronic version, it's the 4th edition, but the hard version is the third one. But the main content are the same. Maybe the number of chapters are different. And there are several reference books, and I can also send you the electronic version. And the content this semester, mainly 2 parts. One part is mechanics, from chapter 2 to chapter 3. That's kinematics, and dynamics from chapter 4 to 6. And work and end chapter 7 and 8. Chapter 9, momentum, and chapter 10 to 11, the rotation. This from chapter 2 to 11. That's about mechanics. That's the first part this semester. And the next part, from chapter 19 to 22, that's electrostatics, and 25 and 26, mechanism, and 27, 28, electromagnetic induction, and electromagnetic wave, chapter 29. This part is called electromagnetism. So there are so many chapters this semester, but we are not going to investigate every section. We only select several sections from these chapters. We have only 56 periods, so time is a limit. So we select several sections from all these chapters. So we are not going to cover all the contents in these chapters. So the final exam 70%, and homework and attendance. So attendance, maybe they will fix the QR code, and after several days, maybe you can use the QR code. And before that, I will use the traditional method. I send a link in the group, and you use that link, and I will help you to check the attendance manually. So, and homeworks. Okay, about homeworks. So, I will send you an electronic version And when you finish that, you send it back to me, and I will provide you a link, and you can submit your homework online. So that's what we do last semester, and this semester will be the same. So that's as for the grading. Together may be 4 homeworks this semester, 4 or 5. Okay, so that's the introduction of this course. So let's go on to the main content. The chapter 2, kinematics in 1 dimension. So we started the simplest case, 1 dimension. So mechanics, this part is called mechanics. In Chinese, it's called 力学. Mechanics is the laws about force and motion. That is called mechanics. So 2 parts. One part is called kinematics, or the laws about motion. So kinematics is the laws about motion. It tells us how the objects move. Chapter 2 and chapter 3 is about kinematics. And the dynamics tell us why they move in this way. So chapter 4 to 11 tell us why they move in this way. So that's the 2 parts in mechanics. The goal of mechanics is to predict the future, because usually we deal with this problem. We know information about this system. We are going to predict, okay, at what time, where it is, and what's the speed of this at a certain time. We can tell you that. That's the prediction. So that's the content of this chapter. So the model here, just like we used when we in previous slides, we use a point mass or a spot to describe this moving object. So we use a point-like object. That is, an object has mass, but of infinitely small size. So we ignore the size and shape of this object and treat it as a particle. So just like a falling ball, a moving car, or a satellite. Or even when I'm walking in this room, you want to describe where the position of my position. You can use this model. Just treat me as a particle. But remember, when you treat something as a particle, that means you are not interested in rotation. Because if you treat it as a particle, whether it rotates or not, it doesn't make any difference. So that's something important. When you want to use this model, that means you are not interested in the rotation. Just like the example, you want to describe my position in this classroom when I am walking. So you can use that model. But if you want to describe the exact motion, my exact motion, when I'm walking, my hand is shaking like this, swinging. Every point on my body move in different ways. So in this case, you want to describe the detailed information of the motion of the different parts of this object. You cannot use this model. So this is not a mathematically a point, but not a physical point. Actually, it has a finite size, not infinitely small. So if we treat it as real physical point, there is no collision. So because why the collision can happen? Why one object will collide with the other? Because they share the same spatial region, so they will collide. So that's why we just ignore the size or the shape, but it's not really has no size or no shape. Okay, maybe it's time to take a rest, right? 11. Okay, it's time to take a rest. We will go on after 5 minutes. Okay, let's go on. So particle model or point mass is the model that we used in the following chapters. So when we describe the position of an object, we often choose another object as a reference. But in different reference frame, the motion can be different. So just like here, if you are on this track, you will see this mass moving up and down, up and down. But if you are on the ground, you may see this guy as moving. If you are on the ground, you may see this guy is moving like this. So that means in different references, you see different things. So, but you need to choose one because when you tell the others, okay, just like here, you say you are at rest, but the other guys may be someone in a car outside. He will say you are moving. So which one is correct? So both of you are correct because you choose different reference. So, but when you communicate with the others, you have to tell them which reference you choose. So the first thing is you must specify a reference frame. Choose a reference frame, but which one you choose, it will not affect the laws of physics. It just affects what you see, but it will not affect the laws of physics. So that means you can choose anything as a reference as you like. You can choose anything as a reference as you like. Okay, so we in kinematics, when we describe the motion of an object, we often use xt diagram or position time diagram, like this diagram. But in this diagram, remember that this curve is not the path of the motion. The horizontal axis is the time, and the vertical is the position. So this object will start at A and then move to B, and then C, and then move back to D and E and F. So when you draw an XT diagram, it's something like this. But the path is on a straight line, right? It go and then go back. It's a one-dimensional motion. So when you draw the path of it, it should be like this, and then like this, not this one. They are different. So this XT diagram is not a path of motion. There is not the path in which the object moves. And the displacement, the first quantity, the displacement, it's called, also we can call it 位移, 位移, in Chinese, 位移, displacement, the change in position in some time interval. So it starts at xi, the initial position, and end at here, and then here, final position xf. So displacement delta x is equal to xf minus xa, the final position minus the initial position. That is called displacement. And the displacement is a vector, which means it has direction. The direction of this displacement is point to the final position. Start from the initial position and point to the final position. Start from xi and point to xs. But it's a one-dimensional motion. So we can just use a positive and a negative to describe its direction. If we choose a positive direction, if the direction of this displacement is the same as the positive direction, that is called positive. And it's in the opposite direction, that's negative. So we use positive or negative to describe the direction of the motion. And there's another quantity called distance. In Chinese, it's called 路程, the length of the path that the object actually travels. The displacement is a vector, while the distance is a scalar. So the distance has only magnitude, and it does not have a direction. But a vector displacement as a vector, it has both magnitude and direction. So, but displacement has magnitude and direction. Distance has only magnitude, has no direction. So for a particular motion, one-dimensional motion, what's the relation between displacement and the distance? Do they have the same magnitude? So actually, they do not have the same magnitude. So in the common cases, they do not have the same magnitude. For example, let's see here. The motion in this along this axis, maybe at time A, it's here at x is equal to 30, and at time B, TB, it's at position here, and then it moved to here, 40. And according to the definition of displacement, the magnitude of the displacement is this final position minus the initial position. So the displacement is 10. From here to here, then back to here, the displacement is 10. But distance is the length of the path. So when it moves from here to here, it travels like 20, and then go to here, 10. So together is 30. So distance is 30, but the magnitude of displacement is 10. So they are not the same. So that means the displacement and the distance, usually they do not share the same magnitude. But there are special cases when it is some objects moving only in one direction. If it does not move back, it's always in one direction, straight forward. They may have the same magnitude. So that's the displacement and distance. And then the velocity. When you want to describe how fast it is moving, you need to use the velocity. The average velocity, 平均速度. So velocity in Chinese, 速度, velocity. The particle's displacement divided by the time interval during which the displacement occurs. That is called average velocity. The average velocity. And the speed and the velocity, they are different. The speed is equal to the distance over time interval. The distance divided by time interval. But the velocity is equal to the displacement divided by time interval. As displacement, magnitude of displacement and distance, they are not the same. So that means the speed and velocity, they are not the same. So, what's more, the velocity is a vector while the speed is scalar. So they are not interchangeable in physics. Okay, so let's check this. If you want to describe how fast the speed is changing, you need to use acceleration, 加速度. So in order to help you to understand why we need acceleration, so just ignore that we do not need to break into groups because there's only one student sit in the classroom and the other students are online. It seems not possible to break into groups. So just think it by yourself, think over it by yourself. There are 3 pictures, and here for choices, we want to find out which picture corresponds to which description. So which motion diagram shows a person or a car? And let's see the first one. Which one is moving with a constant speed? A, B, C, which one is moving in constant speed? So you can tell me on the screen, or you can also send it your choice in the group. That's the same. So what do you think? Yeah. Yes. Yeah. Okay. So maybe the others also choose D, C. Yes. So why C? Because the gaps the same, right? So according to definition of average speed, so the gap are the same. So the time interval should also be the same. So that's why the speed is the same. So that's why the C is moving with a constant speed. So then which one is speeding up? Which one is speeding up? So which one? Okay. Your choice is different from the others. Some of you choose A. A is speeding up. Some of you choose B. Which one is correct? So let's see here. If you are speeding up, that means, for example, we say the average speed, right, is equal to delta x over delta t, average velocity or speed, average speed. We use this bar to indicate the average, maybe distance, s for distance over delta t. Delta s is distance, right? Okay. So no matter which one we use, okay, the gap here become larger and larger. So that means the delta x from here to here to here to here become greater and greater. Or delta s, that's the same. But for the first one, the gap is smaller and smaller. So this gap corresponds to here delta x or here delta s. So in picture A, delta x becomes, that means the speed becomes smaller and smaller. And for this one, the speed is greater and greater. So that's why this one is slowing down, and this one B is speeding up. Because the gap is greater and greater. That means in the same time interval, he moved a longer distance. That's why the speed is changing. So in these three cases, and okay, absolutely no one is at rest, right? Because all of these three is moving. So, okay, that means speed can change. So if you want to describe it, how fast the speed is changing, you need acceleration. Okay, but that's not enough. Just like here. Okay, it cannot play, and I will use this. So maybe you have watched this match.
Usain Bolt, but here he goes, streaking away already. It's Bolt all the way, he's looking round at Gay. Watch the clock, it's goal for Bolt, and again.
Okay, you know this guy Bolt. So he runs really fast. But you can see that when he's running, at beginning and finally, the speed is not the same, right? During his run, it's not the same. He did not always use a uniform speed. The speed is changing. So we actually recorded the position of Bolt at different time. You can see the interval between them can be different. But if you want to tell the others the exact speed of Bolt at a certain instance, you cannot use the average speed because you just use 100 meters divided by time. That is the average speed. It cannot tell us the detail about the change of the speed, right? So if you want to find out the detail of the speed, you need to find out the speed at a certain instance. So that's external velocity or 速度. If we just say velocity for short, we can just use velocity for short. If you use velocity for short or 速度, we mean instantaneous velocity. If you want to know the velocity of a particle at a particular instant, you need this quantity, 速度, velocity. So how long does this particular instance take? We mean the shorter the better. So if you want the shorter the better, we mean what is the instance? Just less than 1 second. Or maybe almost zero. So we use this limitation. The limitation when the time interval delta t approaches zero, the average velocity of the at the limitation when delta t time interval approaches zero, and according to calculus, this is dx over dt, the first order derivative. So that's speed, or that's velocity. That's velocity, not speed. So speed is different from that. So this graph shows the position of a jogger with the time. So what's the velocity of this geogram according to this diagram. And you can see according to this diagram, this geogram is moving with constant speed, right? So for example, how to calculate? So during this time interval is 5 seconds. It travels from 10 to 0. So okay, I write it here. I can write it here. Yes, a pen. Okay, so almost uniform speed because it's a straight line. So it starts from here and to here. Let's choose just from here to here. So from 10 to 0. So 0, final position, minus 10 over time interval, 5 seconds. So that is equal to minus 2 meter per second. Minus means it's moving in the opposite direction of the positive direction. So, okay, that's how we calculate it from the XT diagram. We can, from diagram, we know the distance, the displacement, and we know time interval, and it's a straight line. That means it does not change its speed. Okay, let's do something more complicated. This graph also shows the position of another geogram at 5 times 5 here. That's the XT diagram. So what happens at t is equal to 5? What happens? So think it over by yourself, and you can tell me your choice on the screen. So you can tell me your choice. What happens at t is equal to 5? It's different from previous one. Previous one is a straight line, and it's different from previous one. Okay, someone choose A. Okay, so let's check this one. So this one is there actually you need okay, someone choose C, and okay, so let's look at this diagram. XT diagram can tell us enough, not only the information about the position, but also the information about speed or velocity. So the velocity v, if we use calculus, is equal to dx over dt. So on a xt diagram, what's the speed? How we know the speed? How can we know the speed? Actually, just for example, at here, what's the speed? The slope of the curve here corresponds to the speed, because the slope here is also slope, if you use k, is also equal to dx over dt. So actually the velocity or speed, because it's one-dimensional, so we just use speed as okay, is equal to the slope of the curves on this xt diagram. At here, 5 seconds, x is equal to 0, but the slope is not 0. So what's 0 slope is horizontal line means 0, right? Horizontal line means 0. Vertical line means infinite. So that's slope. So it's not horizontal. It's like this. So it does not mean stop. And the sign of the slope from here to here, actually they should be lective. Because why is selective? Because this slope is selective. So this slope is selective. This slope is positive, right? So the slope is selective. That means it's always selective. So it will not turn around. It will not change its direction. So why does not change its direction? We can draw its path. If this is x, and it starts here at some position positive, maybe start here, and then move to, maybe here is 0, then move to here, and it's go on moving to something minus, right? Some place minus position, because it go to here, minus position. So it does not change its direction. It's always moving in lective direction, right? So it will not change its, it will not stop, it will not turn around. Let's see the magnitude of speed. The magnitude of the speed corresponds to the magnitude of slope if we take the magnitude. And according to this, it becomes greater and greater. So that means the magnitude of the velocity is greater and greater, which means it accelerates. And this one is not correct. And also this one is not constant speed. In previous diagram, that's constant speed. A straight line on XT diagram, that means constant speed. So XT diagram does not only tell us the position of the object, it also tells us the speed or velocity. The slope at any position, at any point on this diagram, tell us the speed of this particle. Okay, so let's do some calculation. A jet engine moves along an experimental track, which we call maybe x-axis. We will treat this engine as if it were a particle. Particle, its position as a function of time is given by this equation. This equation is the position as a function of time, in which a is equal to 2.10 meters per second square, while b is equal to 2.80 meters. We want to determine the magnitude of instantaneous velocity at t is equal to 5. So if we want to calculate speed, like this kind of problems, we always start with the definition of the velocity. V is equal to dx over dt. We always start with this equation. And you substitute this x into this equation, and then you choose t is equal to 5, you can calculate the magnitude of the instantaneous velocity. So maybe you can try to calculate it by yourself first. Try to calculate it by yourself first. Okay. Use this one. Next time, maybe. Yes, he's alone. Next time, maybe I should bring another camera and put it here, and they can see me. Because in this classroom, they use this camera, so they can only see you. Next time, I can bring another camera here. Because in this classroom, I can choose only this camera. Okay. If you have finished, you can try. You can check whether you have get the same result. So if you calculate this, you can substitute this into here, and then b is constant, so this b will not affect your result. And at squared, when you take first order derivatives, that's 2at. So you substitute a is equal to this, and t is equal to 5 into here. That's about 21. So don't forget this 2, right? Because maybe you should use this equation, dt squared over dt is equal to 2t, right? So, and at squared, that's 2at. Okay, so about this kind of problems, you just use the definition of the speed dx over dt, and substitute the equation for x into this equation, and you can get the result. But still, calculus is important. If you don't know how to calculate this, you should check your books about mathematics and calculus. Okay, in order to describe the change in velocity, we use acceleration. The average acceleration is equal to the change in velocity over the time interval. And we can also define instantaneous acceleration. That's delta v over delta t when delta t approaches 0, or we can use calculus is equal to dv over dt, the first order derivative of v about t. But you can also use the second order derivative. So, but in this course, we use this one more than this one. We use this one more, dv over dt. A is equal to dv over dt. That's the definition of acceleration. Or in Chinese, acceleration is called 加速度, because 速度 means speed or velocity, right? 加速度 means change or speeding up, something like that. 加 means change or speeding up. So 加速度 means a change of velocity. That's acceleration, the change of velocity over the time interval. Or if you want to calculate instantaneous acceleration, that's dv over dt. Okay. As we know, we have already discussed the first one. We have finished the first one, right? In previous example. Now try to solve the second one, B. Determine the instantaneous acceleration as a function of time. We have already finished the first step. That's previous example. Now, step B. Try to determine the instantaneous acceleration as a function of time. Here, the instantaneous acceleration A should be equal to dv over dt, while v is equal to dx over dt. So according to the previous one, this is equal to 2at. And you substitute this one into here, you can solve A. So still you can calculate the Bell-cell first. Okay, so let's do it together. So from previous example, we know v is equal to dx over dt is equal to 2at, while a is equal to this, right? A is equal to this. And then we know a is equal to dv over dt, and is equal to here 2at, substitute here d 2at. A is 2.1, and dt, which is equal to 2a, which is equal to 2a. So the acceleration is equal to 2a, or we can say it's equal to 4.2 meters per second square. Okay, so we can erase all this. So first step, we have already finished this in previous example. The second step, okay, is equal to d 4.2 meters per second t dt, which is equal to 4.2. Okay, this is some basic calculations. You just use the definition. It can help you to calculate the speed or acceleration. Okay. So, and maybe today we can stop here. We can stop here today. So class is over today, and we will meet on Thursday, right? Okay, class is over today. See you next time.
Okay,
See you, teacher.
bye, Lakshay.